All right, as we start out, I see what volume of chlorine can be produced by the electrolysis of 500 grams of aluminum chloride. Very first thing I need to do is I need to come up with a balanced chemical equation. So, using my reaction prediction knowledge, I know that aluminum chloride is AlCl3. Aluminum's a 3 plus, chlorine's a 1 minus. It is undergoing an electrolysis, so it is going to split into the individual elements. It's going to split into aluminum, and it's going to split into chlorine. Remember that chlorine is a super 7, so it is diatomic. So now I have my skeleton equation for the decomposition of aluminum chloride. All I need to do is balance it. I have trouble with my chlorines here. I have odd and even, so I'm going to make this side even so that I can make this side even also. It was already even, but... And then I'm going to finish off by balancing up my aluminum. So, I have a balanced chemical equation now. Looking at the problem, I've given 500 grams of aluminum chloride. So I'm going to start 500 grams aluminum chloride. I am trying to find the volume of chlorine. So I start out going to moles once again, and I like to just run these all in a line. So you're going to see me make a big line as so, because I'm going to roll these all in one conversion box and just start adding some lines. You'll see here in a second how I'm doing so. But I have already calculated my molar mass of aluminum chloride. So the molar mass is 133.3315 grams of aluminum chloride. Put that on the bottom. I want 1 mole of aluminum chloride on the top. So, based on my factor label, I have a label right there that will cancel. So I have essentially converted this now into moles of aluminum chloride. Now I go to my balanced chemical equation. Okay, I see a 2. 2 mole of aluminum chloride. I'm trying to convert this into chlorine, so I have 3 moles of chlorine. That is my second step. I make sure my labels can cancel, which they do. Now I have converted this into moles of chlorine. Now my final step here is the new step we will do. I need to get this into a volume. Well, I know that 1 mole of chlorine gas is 22.4 liters of chlorine gas. So, my moles of chlorine cancel. My final label is going to be liters of chlorine gas. Is that going to give me a volume? Yes, it will. So when I do my math, okay, I'm going to multiply by everything on the top. I'm going to divide by everything on the bottom. And I come up with a value of 126.0017, blah, blah, blah. The reason I'm putting that up here is because I threw one into you that has how many sig figs? 1 sig fig. So what is my correct value for this? 100. No decimal, no nothing. 1 sig fig, 100. Okay? Now, I'll give you a second to write this down. What volume of oxygen is needed to burn completely 35.0 grams of ethyl alcohol? What type of a reaction is this? If we're dealing with our 5 different types of reaction, what type is this? It is not a decomposition. What are we doing? What does it say there? We're burning. So it is what type of a reaction? Combustion. Thank you, Parker. It's a combustion reaction. So C2H5OH plus oxygen will yield, what are our products of all combustion reactions? Carbon dioxide and water. So all I need to do is balance this out. I've already balanced it. So I have a 3 here. I have a 2 here. I have a 3 here. That should balance out my reaction. So I have 35.5 grams of ethyl alcohol. Once again, this is just like the last problem. So I'm going to start out with 35.0 grams of C2H5OH. I'm going to make my long conversion box. We're going to go a while with this. I need to find the molar mass of ethyl alcohol. 46.0688 grams. So I've now converted that into moles of ethyl alcohol. I go up to my molar conversion. 1 mole of ethyl alcohol. And I'm trying to convert this into oxygen. So I have 3 moles of oxygen. We're all okay with molar ratios, aren't we? Balanced equations. So based on factor label, I have a label here. I have a label here that cancels. I've now converted that into moles of oxygen. Final part is converting that back into a volume. Well, I know that 1 mole of oxygen has 22.4 liters of oxygen. Moles of oxygen cancel. Final answer is going to be in liters of oxygen. Once again, I multiply by the stuff on top. Then I divide that by what is on the bottom. And I come up with a value of 51.1 liters. 51.1 liters when I round it to 3 significant figures. Any questions on mass to volume? Could you do volume to mass? Just working that backwards, so to speak? Yeah, I hope. Sulfur dioxide combines with oxygen to form sulfur trioxide. Sulfur dioxide combines with oxygen to form sulfur trioxide. Balancing this baby out, if I put a 2 here and a 2 here, it should be balanced. So, I have my balanced chemical equation. I have 50 2 sig figs because the decimal point behind tells me it's 2 sig figs. 50 liters of sulfur trioxide, right? That's what I'm given. I am trying to find liters of sulfur dioxide. So I set up my conversion box. I first have to go to moles. So 22.4 liters sulfur trioxide is 1 mole. Sulfur trioxide. My liters of sulfur trioxide cancel. I've now converted this into a mole, into moles of sulfur trioxide. I look at my balanced chemical equation. 2 moles of SO3, 2 moles of SO2, correct? So basically my molar ratio there's a wash. Finally, I need to convert this. So let me do my canceling of my labels. Finally, I need to convert this back into liters of sulfur dioxide. Well, I know that 1 mole SO2 has 22.4 liters SO2. Labels cancel. So now my final label, I'll bring her down just a tad. My final label is going to be liters of SO2. But what do you notice, folks? Okay, I've got 2 and 2 in numerator and the denominator. I've got 22.4 in numerator and denominator, right? So everything cancels out. So my answer is going to be 50 liters of sulfur dioxide. Do I need that decimal point behind it? Absolutely. Could I put a bar instead over the top of it? The 0? Absolutely. Could I put that into scientific notation? Absolutely. All of those are the same. Okay? So just so happens that this worked out that everything canceled. So I didn't have to plug anything into the calculator. Let's roll with one final one. Propane is burned in oxygen to yield carbon dioxide and steam. Steam's just water in the gaseous state. I go through to balance out my chemical equation. Put a 3 there to balance out my carbons. That means that I need to put a 4 here to balance out my hydrogens. Doing so gives me 6 and 4 is 10 oxygens, so I put a 5 there to balance out my oxygens. I now have a balanced chemical equation. 8.750 liters of propane. Mental note, I have 4 sig figs. Set up my conversion box. 22.4 liters of methane is 1 mole. It's not methane, it's propane, my bad. 1 mole of propane. So my liters of propane cancel. I have that into moles. Now of propane. I look at my molar ratio, 1 mole. 1 mole of propane. I'm trying to convert this into liters of oxygen. So 1 mole of propane has 5 moles of oxygen. My moles of propane cancel out. I've now converted that into moles of oxygen. I don't want moles of oxygen. I want a volume. So 1 mole of oxygen, 22.4 liters of oxygen. My moles cancel. My moles cancel. So in looking at this, once again, and you're going to see this, folks, that I'm going to have when I'm going volume to volume, I should have 22.4 somewhere in the numerator and somewhere in the denominator, right? If I'm doing volume to volume and I've set it up right. So my final answer is going to be in liters of oxygen. That 22.4, that 22.4 I don't need to do. So all I need to do is take 8.750 and multiply it by 5. Gives me an answer with 4 sig figs, exactly, 43.75 liters of oxygen. So I guess, ladies and gentlemen, let's go back and let's talk a little bit and let's see what exactly is this telling me. What exactly is this telling me? Well, it tells me that if I have 8.750 liters of propane, I need 43.75 liters of oxygen to react 100% with that 8.750. Okay? That's how much oxygen I need in order to produce the carbon dioxide and to produce the water. So those values would give me a 100% reaction of the 8.750 liters. Okay? Anybody do this? Anybody ever use propane? Where do you use propane at? your grill. If you've got a gas grill, you're probably using propane and this reaction's occurring.